Okay, notes for section 4.5. This is going back and covering day 1's material since we did day 2 yesterday. We're looking at tangent and cotangent graphs today, involving the same transformations that we've been doing for the last week and a half or so. All right, so I need you to fill in the tangents of all of these angles. We're going to start with 0. All right, so using your unit circle, tangent is defined as what? Yes, sine over cosine, all right, which in our case would be our y-coordinate over our x-coordinate. Yes? Okay. All right, so if our angle is 0 radians, we are on the positive x-axis. What's the ordered pair there? Okay, so if we have the point 1, 0, what would be the tangent? 0 divided by 1, which is 0. All right, so at 0 radians, our tangent is 0. Let's look at our positive ones. At pi over 6, what's the ordered pair at pi over 6? Okay, root 3 over 2, 1/2. So tangent is going to be 1/2 over root 3 over 2. How does that simplify? 1 over root 3 rationalized would be, okay. Now, what would happen if we went to negative pi over 6? So going down in quadrant 4, right? What happens to the coordinates that I had here? What becomes negative? The y becomes negative in quadrant 4? Yes? Okay. So if we made that negative for negative pi over 6, what happens to our tangent? It just becomes negative. All right. So at negative pi over 6, we're at negative root 3 over 3. Now, will that same pattern continue if we go, say, positive pi over 4 and negative pi over 4? Same idea, right? Okay, what are the ordered pairs, or the ordered pair for pi over 4? So what happens when we do the tangent? We just get a 1? All right, so tangent at pi over 4 is 1, which means tangent at negative pi over 4 would be negative 1. All right, pi over 3's. What's my ordered pair at pi over 3? Okay. Tangent would be root 3 over 1, right? The 2's would drop out again. Can you visualize that? So tangent here would be root 3. For the negative version, we have negative root 3. All right, last one, pi over 2. What's my ordered pair at pi over 2? 0, 1. What happens when I do tangent? It's undefined, right? 1 divided by 0 we can't do. So we are undefined here and here. Okay, now using your calculators, let's get some options here in decimal form. What is the square root of 3? Around 1.7 something? Okay. How about root 3 divided by 3? Okay. So if we were to plot all of these, and don't worry, you won't be plotting all of these for every graph, but if we were, we have 0 here. We said our point was 0. At pi over 6, we are at 0.57 roughly. Okay, and then we'd at negative 0.57 for negative pi over 6. At pi over 4, we said we were at 1 and negative 1. And at pi over 3, we said we were at about 1.7 or negative 1.7 here. Does that make sense? By the time we get to pi over 2, we are undefined, which means we have vertical asymptotes. So any place in your t-chart where you get an undefined, that's a vertical asymptote. So the shape you see here is a typical, the parent function for tangent. All right, this is one period. You get one curve like this. Kind of looks like a cube, right? The cube twist kind of a thing. What's going to be important today is to distinguish between tangent and cotangent. They look very similar. Tangent twists this way. We're going to get to a cotangent one in a minute. We could reflect this. We could shift it left and right, do a phase shift. We can stretch or shrink horizontally to change the period of it. All right, we can do all the transformations that we've been doing now with this curve. Hopefully by now you've got sine and cosine down. You can picture the shape of it. You can picture normal period goes from 0 to 2 pi for one cycle before we do any shifting or anything. Okay, you've got those locked down hopefully in your mind. You have two new ones today. Tangent, notice, is split. Our vertical asymptotes, we have one over here at negative pi over 2. We have another one here at positive pi over 2. So your period is split half on the left side of the y-axis and half on the right. Okay, with your center point right being at the origin. This picture you need to get in your mind. Okay, when I say what does a tangent graph look like, you need to say I'm going to start low and twist high, and I'm splitting it half and half, half on each side. Okay, all right. Let's see. So period for tangent is only pi, right? From negative pi over 2 to positive pi over 2 is the space of just 1 pi. We've talked about our graph being undefined. Wherever we have those vertical asymptotes, our graph is undefined. All right, so what caused our vertical asymptote? When it was undefined, when we were trying to take the tangent and it ended up being undefined, what made it undefined? The x-coordinate was 0. Cosine was 0, right? Because tangent is sine over cosine, we can't divide by 0. So tangent has asymptotes wherever the cosine graph was 0. All right, so looking at this picture, our cosine graph is the blue one. Wherever we hit 0, we'd have an asymptote for tangent. Okay. Tangent has zeros where? Which coordinate would be 0 to give me 0 for an answer? The sine, the y-coordinate, right? So we have zeros wherever the sine curve hits 0. So for our graph, sine is red. We're going to have a 0 here, here, and here. Okay. So we're going to get one period drawn again for this. Try not to look back at your previous sheet. Where does tangent start and end? Negative pi over 2 to pi over 2. So we want to split it half and half on either side of our y-axis. So we're going to have negative pi over 2 here and positive pi over 2 here. We want to split it into 4 chunks, just like we've been doing for sine and cosine, secant and cosecant. So split this into 4 chunks. We have to cut each of those sections in half again. What are the tick marks going to be labeled for those? Good. Pi over 4 and negative pi over 4. Okay. Vertical asymptotes at negative pi over 2 and at positive pi over 2. Now I told you to start memorizing the shape of a tangent curve. It starts where? Starts low and twists high. Yes? So, starting low. Well, what does low mean? We're not going to graph every single ordered pair on our unit circle, right? We're not going to graph pi over 6s and pi over 3s. Which are the easy ones to graph? I'll flip back here. In this T-chart, what would be easy to plot? Oops. Yeah, pi over 4s, right? 0, that's easy. That's easy. If we know the basic shape, we know where we have vertical asymptotes, and we know our 1s and our 0s, we can get our graph. All right, we don't need to worry about all the root 3 over 3s and the root 3s. Okay. All right, so we have a 0 halfway in between. That's an easy one to plot. And we said we're going to start low and twist high. So my tick mark to the left is going to be a low point. In this case, my low is -1. All right, so we'll mark this -1, +1. I'm low here. Some different colors. Okay, the one to the right is going to be high. Now be careful, because if you just graph those 3 points, it looks like a line. Yes? But we know a tangent's not a line. We know it has that twist shape to it. So when you draw it in, make sure you're showing that. It's going to come from low, approaching that asymptote from way down here. It's going to come up and twist through there and go high. Okay? All right, some characteristics about the tangent curve. What did we say the period length was? Pi. Okay. We do have zeros. Where do they happen? Go back up here. They happen at 0, right? We have one here. We have one here at pi. We have one at 2 pi. If we kept doing more and more periods, right, you'd see those showing up. So 0, 1 pi, 2 pi, 3 pi, 4 pi. We could go in the negative direction, negative pi, negative 2 pi. So our zeros are going to happen at n pi, wherever the sign was 0. Where did we have vertical asymptotes? Where the cosine was 0. So at pi over 2s, right? Positive and negative pi over 2s. Where would the next one be? How big is the period? Pi. So if we're at pi over 2 and we add another pi, 3 pi over 2. Add another pi, we're at 5 pi over 2, 7 pi over 2, right? That's where your vertical asymptotes are going to happen. So where the cosine is 0, which happens at pi over 2s, and then we just keep adding pi or subtracting pi from it. Okay. We don't have horizontal asymptotes. What about domain? Yesterday we said domain was tied to what? Tied to what? The vertical asymptotes. All right. So our domain is going to be everything but where we have a vertical asymptote. Okay. Range is all real numbers. It's continuous on its domain. It has odd symmetry. When we talked about secant and cosecant yesterday, we had max and mins, local extrema. We aren't going to have that here. Your tangent curve continues, right? To have a maximum or minimum, you have to go from, say, increasing to decreasing or from decreasing to increasing. We don't have that here. A tangent curve is increasing throughout its cycle. It's not bounded. And in terms of end behavior, it's the same thing we've had with the other trig functions. Does not exist. Okay, we're going to continue to bounce between negative infinity and positive infinity, and there's no limit. Okay, so are we experts now on a tangent curve? We will be by the end of the day. I know you're excited about that. Okay, let's move on to cotangent. Cotangent is defined to be what? Which ratio? Cosine over sine? Okay, so it's similar to what we just talked about, except we're going to flip-flop everything. All right, so cotangent has zeros. Now, where the cosine is 0, and we have vertical asymptotes where the sine is 0. All right, so let's look at our unit circle. We have a point here at 1, 0. Here we had 0, 1. So what is the cotangent at 0 radians? What is the cotangent here at 0? Cotangent is cosine over sine, right? So 1 over 0, undefined. Okay, so at 0, we are undefined. We'd have a vertical asymptote. Because I'm trying to divide by sine, and sine is 0 here. Okay, doesn't work. Where else would I have a vertical asymptote? Where else is the sine 0? Here? Here? Yes? How far apart are those, each asymptote? Pi. So period is pi again, right? So for your secant, cosecant, sine, cosine, it's 2 pi. But for tangent and cotangent, it's 1 pi. So we have vertical asymptotes at 0 and pi. Where are we going to hit 0? We said we had a 0 where the cosine is 0. Well, where's cosine 0? Cosine is my blue curve here. At pi over 2. Halfway in between where I have my asymptotes drawn. Okay? So at pi over 2, I'm going to have a 0. Now we want to split this into 4 chunks like before. So we've got our pi over 4s. We've got our 3 pi over 4s. What's the cotangent at pi over 4? It's 1. If you look at your picture up here, right, at pi over 4, your sine and cosine are the same, right? The two graphs are in the same spot. So if you take cosine divided by sine and they're the same values, you get 1. So at pi over 4, my cotangent is 1. What happens at 3 pi over 4? We'd be at negative 1. Okay? In your unit circle, 3/4 is over here. It's still going to be that root 2 over 2 combination for your ordered pair, but your x-coordinate would be negative. Okay? So cotangent's going to be negative 1. So it looks a lot like a tangent curve that's been flipped upside down, that's been reflected. This one starts high and twists low. Okay? So the two things that are different, tangent starts low and twists high, cotangent starts high and twists low. The other difference is tangent, remember, is split half and half on each side of the y-axis. whereas cotangent is all, one period is all to the right. Yes? Okay. Some characteristics. Period is pi. We had zeros where? At pi over 2, and then they're going to keep recurring every pi after that? Vertical asymptotes happened at 0, at pi, next one would be at 2 pi, 3 pi, right? So they're going to start at 0 and go to each pi after that. How about horizontal asymptotes? None? Domain tied to vertical asymptotes. So you're taking the same thing you had for vertical asymptotes, you're just putting a not equal sign in there. All right. Range is all real numbers again. It's continuous over its domain. It's another odd function, which means if we're taking the cotangent of a negative angle, it's the opposite as what we had for the cotangent of the positive angle. There are no extrema. We don't have any major turns happening. This time it is decreasing on each interval. It's not bounded, and end behavior does not exist. All right, anybody need me to pause the video to catch up? All right. So we want to graph some of these. I know this is what you've been waiting for, right? First one says, to describe the graph of the function y equals a negative tangent of 2x in terms of a basic trig function, locate vertical asymptotes, graph 4 periods. They're making us work hard on a Friday. Don't worry, you won't have to graph 4 for everything. Okay, what can you tell me about the graph? There's a reflection over the x-axis, same as everything else that we've been doing. Okay, what does that 2 do? Okay, horizontal compression by a factor of 1/2. Okay, so in terms of the period, normal period for tangent is 1 pi. We have to divide by b, right, to shrink this. So we're dividing by 2. Period now is pi over 2. Increments would be what? Pi over 8. Don't you love all the fractions? All right. Now, tangent normally starts and ends where? One cycle. Remember, this is the one that's split, right? Half on the left, half on the right. So normally we go from negative pi over 2 to pi over 2. That's our normal one. Our middle term here is a 2x, so there's going to be a 2 there, which means what? Now we're going between negative pi over 4 up to positive pi over 4. Is that still a span of pi over 2, which we said the period should be? Yes? A fourth plus a fourth on either side would be a half. Okay. We haven't done any kind of vertical shifting, any kind of horizontal phase shift. We haven't done any kind of vertical stretching. We've just reflected it and scrunched it horizontally. Okay, so let's get our tick marks labeled. We want to go by pi over 8s. Okay, so this is going to be pi over 8, pi over 4. On the left side, we would have negative pi over 8 and negative pi over 4. And that's going to be 1 period. Go ahead and draw your vertical asymptotes in. Now they told us to graph 4 periods. In terms of labeling your tick marks, it can get pretty messy and cluttered if you have to label all of them. You must label the tick marks for all 4 tick marks inside 1 period. But beyond that, I'm okay with you just marking the ends. Okay? So if we go another period, which we said was pi over 2, same as 2/4, yes? So we were at 1/4 here. If we go 2/4 more, we're at 3/4. Okay, so go 4 tick marks, draw another asymptote in, and we said this one was 3/4. Where would the next one be? 5/4. Okay, now that's 3 sets, right? That's 3 spaces for periods. We need 1 more, so let's go on the left. We were at negative 1/4. If we go left another 2/4, we're at negative 3/4. Okay, that'll get us the 4 periods. Now, what did we say about the points? Which ones are we plotting? We're not plotting all the pi over 6s and the pi over 3s, right? We're doing the ones where the tangent, cotangent are 1s, 0s, negative 1s. Okay. It is a tangent curve, so normally it starts low and twists high, but what have we done to it? We've reflected it. So it's going to start high and go low. All right, so for my normal period, and you don't have to put these dots in because we're going to move them. Normal period, I'd have a 0 in the center. I would start low and go high, but we said we're reflecting this. So we are going to start high and move low. Okay. All right, so there's 1 cycle. Can you copy that same picture 3 more times? Yes. Just draw your points straight across. So my high point here was at a 1, then I was at 0, negative 1. I'm at 1, 0, negative 1. I'm at 1, 0, negative 1. Right? And then draw your curve in. Okay. How about this one? What kinds of things do you see happening here? Okay. Now, one thing to note, with tangents and cotangents, we don't call it amplitude anymore. With sines and cosines, it was kind of our high and low cutoff, right? And our graph stayed within that range. Because our graph continues vertically from negative infinity to infinity, we don't call it amplitude. We would still refer to that as a vertical stretch by a factor of 3. So those points that we've been graphing, where we had, you know, a 1 here, a negative 1 here, we are going to just stretch those. So now they're going to be 3s and negative 3s. Does that make sense? That's what that vertical thing is going to do. All right, what else do we know about it? There's a horizontal stretch, yes. Let's look at what happens to the period. Because this is really saying 1/2 x, right? And period is normally 1 pi for tangent and cotangent. We're going to divide it by 1/2, our b term, but dividing by 1/2 is really the same as multiplying by 2. So the period becomes 2 pi. So we've stretched it to twice as big. Okay. What are the increments going to be? Cut 2 pi into 4 chunks. Pi over 2s. Yep. Okay. Have we done any kind of phase shift? Left-right move? No. Have we done any kind of vertical move? Yes, we are going up 1. Okay, so let's look at where we normally start and end a cotangent curve. Normally, we are between what values for cotangent? 0 to pi, yes. All right, inside we've got x divided by 2. How are we going to get rid of that 2? Multiplying both sides by 2 gives me 0 to 2 pi. Notice that I am not putting equal signs on this because we have asymptotes there. We don't actually touch them. So we're going to have vertical asymptotes at 0 and 2 pi. Okay. We're going in increments of pi over 2. So here's my first vertical asymptote at 0. We said we've stretched this, so I want you to visually see that. We're going to go every other tick mark on this graph so that you can see it being stretched. So this is going to be 1 pi over 2 here. This would be pi, 3 pi over 2, and 2 pi. And that's where my next asymptote is going to be. Okay. Let's draw the same thing on the other side. It's asking me to do 2 periods for this one. All right. Cotangent normally starts where? In terms of my graph, sorry, if I'm graphing my points, my first point is high and then low? High, 0, low? Okay. We have 2 things happening here. We have stretched it vertically, so when we put our dots in, instead of thinking 1s and -1s, we're going to think 3s and -3s. But we've also shifted up 1. So if you don't want to put the first set of points in and you want to just wait and do the final ones, that's fine. But normally, if we didn't have the vertical shift, we would have a point here at +3, then 0, then -3. Does that make sense? That's the vertical stretch part. We now need to move our dots up 1. So we're really going to have a point here, here, and here. If it helps you to draw the new 0 line in, you can. The reason I don't usually do that is we have very few points that actually hit that line in our graph, and I think it just makes it look more confusing. Okay, but you certainly can. Copy these same points over in our next period. So the first tick mark here is going to be the high point, our middle point, and then our low point, which in this case would be a 4, a 1, and a -2, since we shifted everything up 1. Okay, and now draw it in. Questions so far? All right, we have 4 more. Going to look at our different transformations here. So tell me the 2 things you see in the first one. Vertical stretch of 2 and up 1. Okay. We have not changed the period. We have not do any kind of phase shift. So what is normal period here? Normal period is 1 pi, which means increments are in pi over 4s. Okay. Where do we normally start and end? Like, where would our asymptotes be for a tangent? This is the split one, right? Half on each side. So negative pi over 2 up to positive pi over 2. All right. Let's go ahead and draw in the asymptotes. We have one here at pi over 2 and one at negative pi over 2. It does ask for several cycles. So let's get maybe one more on either side of this. Where would my next tick mark on the right be? All right, and over here at negative 3 pi over 2. Okay, tangent, visualize it in your mind. A tangent curve looks like what? Goes from low to high. Okay, we haven't flipped it over. We've stretched it a little bit. So instead of 1 and negative 1 points, we're going to have stretching it by a 2, right? So we're going to have 2's and negative 2's. Okay. However, we have to move everything up 1. So let's get our zeros in first. We would have a 0 in the middle of each one. We said we're stretching it to negative 2 and positive 2. And now we're going to shift everything up 1. All right, so we have a dot here, here, and here. Copy those 2 more times. And draw your twist in. All right, next one. What 2 things do you see happening? Everybody, nice and loud. Good. Okay, what else? Down 1? Okay, no phase shift, no change in period. It's standard, yes? So period is 1 pi, increments are pi over 4s. Where, though, does a cotangent start and end? Cotangent's all to the right, yes? 0 to pi? Okay. All right, so we're going to go 0 to pi. Let's get our asymptotes drawn in. We need a couple cycles. We could do one more over here on the right, one on the left. Cotangent normally does what shape? Start high, twist low. But what are we doing to it? We're reflecting it, right? So it's going to reflect. It's going to go low to high. Okay. So low to high. Have we done any kind of vertical stretch? No. Okay. So middle dot 0, low would be negative 1, high would be positive 1. We haven't stretched it at all? Okay. It's going to look an awful lot like what? It's going to look like a tangent curve. That's the one problem with cotangents and tangents. They look so much alike. Simply by reflecting it, you get the look of the other one. You know, I did this last hour too. I forgot the down one. All right. Here we go. Move them all down 1. All right. The board seems to be off a little bit here. Okay, we have 2 left. What do you notice about these? They have phase shifts. Wouldn't want you to go a whole weekend without trying a phase shift on a tangent or cotangent. All right. Have we done any kind of reflections? Any reflection on the first one here? No. Any vertical stretch? No. The only thing we're doing is changing horizontally where we're located. Okay? So let's look at what happens. We have 2 times x minus pi over 4. And normally tangent starts and ends where? Yes. From negative pi over 2 to positive pi over 2. How are we going to solve for x here? Divide a 2 out of both sides, which makes this negative pi over 4 and positive pi over 4. Okay, now what? Add the pi over 4, which makes this 0 and this pi over 2. Now, does that fit with what we think the period should be? Think about it. Period would be pi divided by this 2. Going from 0 to pi over 2 is space of pi over 2, right? That fits. We've shifted it, though, pi over 2 to the right. Okay, and that's what we had here. If we had multiplied the 2 back in. Yes? Okay. Sorry, I should say we've shifted pi over 4 because we've scrunched it, right? It's half its size. Okay. So let's get asymptotes drawn in at 0 and pi over 2. What do you think we should use for increments here? Pi over 8s, right? If the period is pi over 2, increments are going to be pi over 8s. Okay, so we've got 1/8, 2/8, 3/8, 4/8. That would be my 1/2, right? My endpoint. Okay, so we have pi over 8, pi over 4, 3/8 for that one, and then pi over 2. Okay, let's get one more cycle drawn in here. It is a tangent curve. Tangent starts where? Low to high? Okay, we haven't flipped this at all. We haven't vertically stretched it at all. So my points are going to be negative 1, 0, 1, low to high. All right, no vertical shift that I can forget about doing. All right, so low to high would look like this. Yes? All right. Where is that last asymptote? What would I label this tick mark? This would be pi? Okay. All right. Could you draw more of them if you needed to? Yeah. All right. Last one. What's the 2 in front going to do? All right. So we are going to stretch to 2 and negative 2 for our dots. Notice that the 3x minus pi over 2 is not factored out. Okay? So it's harder to see the phase shift. Let's set it equal to our normal start and end. All right, it's cotangent. What are my normal start and end points for cotangent? 0, 2, pi. All right, what's going to happen here? We'd have to add a pi over 2 to both sides. Pi plus another pi over 2 would give me 3 pi over 2. And then we have to divide the 3 out. What's that going to make this on the left? Pi over 6. This I'm going to write as 3 pi over 6 just for a minute. I know we can reduce that, but I want you to think in terms of sixths. Okay, we're going from 1/6 to 3/6. That's a space of 2/6 or 1/3 pi. Okay, is that the period? Well, we have a 3 there, right? Period would be pi divided by 3. Yes, so that's fitting. What kind of increments should we think of for our tick marks? Yeah, pi over 12ths. Okay, so this has been horizontally compressed to 1/3 of its normal size. We're not going to be able to show visually that we've compressed it much just because it's going to be hard to make our tick marks even smaller than they are. All right, so let's go ahead and just go by pi over 12ths for each tick mark. We are starting at pi over 6. So if we think of this as 1/12, try to get it in the right spot here. This would be 2/12ths, which would be my 1/6. Okay, so this will be pi over 6. Then we have 3/12ths, which would be what? Okay, I'm going to write my tick marks down here just because it's getting too small there. So my first mark is going to be at pi over 6. I add another 12th to that, which makes it 3/12ths, which we said was a 4th. Okay, 3/12ths adding another 12th puts it at 4/12ths, which would be pi over 3. That was 4/12ths. Our next one would be 5/12ths. Our next one would be 6/12ths, which is a half. Okay, so does that fit what we said here? We're starting at pi over 6, right? We're ending at 3/6 or a half. Does that work? Okay, so we've got pi over 6. Our first vertical asymptote is going to be there at 1/6. And then we need to go 4 spaces over. And we said that would be our pi over 2s. Yes? All right. It was which kind of graph? Cotangent. Did we flip it at all? Reflect it? No. So cotangent's going to start high and go low. Okay? We have to vertically stretch it, but we don't have to move it up or down at all. Okay. So vertically stretching it means high is now going to be a 2 and low is going to be a -2. So I'm going to have a dot here. 0, -2. Agree, disagree? We okay with that? All right. Could you graph more periods if you had to? Yes? All right. So homework, remember we flip-flopped our 2 days, so this is actually day 2.